Okay. So when we have this data type, identifiers, what are identifiers? Identifiers are the name that are given to the memory locations. It could be a class, it could be a variable, it could be a constant, any identifier we define with the help of this. So each identified object in the computer is stored at a unique address. It is storing at somewhere in the memory location, right? And it is holding an unique address. We cannot say that all identifiers are saved at the same location. No, they are stored at a unique address, right? So let us understand the next thing, how we define, what are the rules of identifiers. Whenever we define the name of identifier, what are the rules, what are the best practices for defining them? The first practice that we have to use is, first character must be alphabetic character or underscore. So there are three things that are allowed in identifiers. It includes alphabets, it includes numbers and underscore. No other special characters are allowed. So only three things are allowed. What are those? It may consist of alphabet characters, digits or underscores. First 63 characters of an identifiers are significant. So I'm going to show you the list, how they are stored in memory, what is the ASCII value of these in memory, how we stored them in, like how we store uppercase A and how we store a lowercase a. What is the ASCII value of them, right? Cannot duplicate a keyword. So we cannot duplicate, we cannot make a replica of the keywords. They are basically, they are defined in the memory. They have their special meaning in the library also. So there is one note, there is one point to be remembered. An identifier must start with a letter or an underscore. It may not have a space or an hyphen. So we cannot say that you may include, like let's suppose I want to name of a student. Yeah, student name. So it could be written student underscore name. It should not be like this, student hyphen name. Yeah, student space name, right? How we are going to write it? Student underscore name, right? Yeah. So I told you the lowercase a and the uppercase a, they both have different ASCII values, right? So C is a case sensitive language. We will, when I'm going to show you for both the cases. Let us see, these are the valid names, how to define an identifier. Suppose we are defining A. So A is a character, it could be possible, but it's a poor style because A is irrelevant name. This is not a relevant name, right? Then we have student name. Student, that's what I was telling you, student underscore name. Or you may have the third identifier name is a system name. This could also be possible. Then underscore bull, so for storing the boolean values. Int underscore min, so this is system defined value. How to define it in the system, because int is, again, when we call int we cannot take it as this, right? And then what are the invalid names? We have valid names. We have seen the we have seen how we define the identifiers. Let us talk about invalid identifiers. First symbol you have used is dollar, that is sum. So yes, we cannot use special characters in defining, while defining the identifiers, right? You cannot have this. This is illegal and it is going to give you an error. The first character should be underscore or alphabet. So obviously it is a number, it gives you an error. The third thing is you have included hyphen. Sum hyphen salary, right? So it is not allowed. It is going to give you an error. Student space number. Again, spaces are not allowed. So it is going to give you an error. Int. Int is an identifier. No, int is already a reserved word. That is a keyword for storing, for holding the numbers, digits, values. So it is going to give you an error when you define such kind of names. Now these are the basic data types of C. What are the basic data types that we have in C? First is a void. Void means nothing, null. Integral. Integral may we have Boolean values, character values and integer values. In floating point number, or you may say when you have decimal point numbers, you may represent it with floating point numbers. What is that? Real, imaginary and complex. Then we have derived data types after this. So let us start with that. The first data type, that is char. You may have some, like if you want to hold some larger values of char, you may use other part, that is w char underscore t, right? Then we have integer for storing the integer values. The smallest integer, the shortest range of this is short integer. Then we have int for storing the numbers. Then if we have, or beyond this, like the limit, we are storing the large values of integers, large values of numbers, we may be using long. And again, if you want to again have another a big value in numbers, you may use long of int. Right, so this is how we maintain the sequence in integers. So within integers we have a wide range of data types, right? But it is holding the data type, that is int only, right? Means it is storing for numbers only. Whereas in char we are holding the characters only. Let us see for float. Now, before moving to the float, let us see the sizes and the values for signed integers. So the type is short int. I told you, I have shown you in the previous slide. It takes 2 bytes in memory. And what is the minimum value that is going to be stored? That is minus 32768. And what is the maximum value that is going to be saved for short integers is 32767. So it is holding the values between these. This is the particular range. And how much byte it stored in memory? That is 2. Right? Then we have integers. Integers are taking 4 bytes. Then long integers 4 bytes. Then long integers, it is holding 8 bytes. So this is how they are holding. Again, the ranges are also changing. So if you are taking with 4 bytes, minus 147 483648. And what is the maximum value? That is 2147 483 and 647. So it has a wide range for holding the int values. Then we have long integers. Again, it takes 4 bytes of memory in 4 bytes in memory. What is the range? The same range is there for long integer also. Then we have long int, a wide range of numbers. Minus 223 372 036. So whenever we are using, we are occupying a 8 byte. It takes 8 byte, right, in memory. Now let us move to the next data type, that is float. So first of all, like the smallest, you may say when we have decimal point number, we usually take the float data type. If we have longer values, large values for float numbers, floating decimal point numbers, we may be using double for it. And again, beyond that, if double does not work, we have a large number of values in that particular variable, we may be using long double for it. So have you seen this thing? Long is added to integers also, and long can be added to double or float also. So we usually use long double for storing the large number of decimal point numbers. So let us see how we use the data types in C. This is the summary what we have till now understood. Void means nothing. It returns null values. Void is the type which is null. Null means nothing to be returned. Integral may we have 3 types of data. The first is Boolean. When we have true or false kind of thing, 0 or 1 kind of thing, we will be using Boolean data type. Then we have characters. Characters may be, again we have 2 things, char and wchar underscore t. Then we have integers. In integers we have short int, integers, long int and long int, right? So these are the different types of data under the class that is integer. Then under floating point numbers, floating point data type, we have real, imaginary and complex data types. In real, we have float, double and long double. Under imaginary, we have again the same thing. Float imaginary, double imaginary, long imaginary. Right? And complex means same as imaginary, you just need to replace it with complex. Float complex, double complex and long double complex. Right? So these are the data types we have in C language. Next is, let us see how to use these variables in our program. How to use these data types in a program. So for using the data types, we have some variables that is storing some value. Right? Because for that value, we need the data type. Yeah, so variables are the named memory locations that have a type. Type means what is the type of data. Type of data means it could be integers that just now we have covered. It could be a character, it could be a decimal point number which is inherited from their type. The type determines the value that a variable may contain and the operations may be used with its value. So let us see directly the implementation of this. Whenever we define any variable, how to define the data type with that. So we have the data type that is char, right? What is the type of variable? Then space and the variable name. The variable name is code. Code means it is containing some characters. It should be like the value that is to be stored in code is of variable, is of character, right? Again in the next statement, integer I, it should be holding some numbers. Long, then it is having some long type of numbers, right? And then we have floating point numbers. What is floating point numbers? Decimal point numbers. Float, decimal point numbers. Double pi means you have a decimal point number which is holding some large values. So these are the data types that we have in our C language and how we basically declare it in C language, right? Let's see some of the examples how we use this data types in our C. Now for are you able to see like after each statement semicolon is used to end the line. So semicolon is used to basically why we use semicolon? Semicolon we use to end the line. Now suppose we have a first data type that is bool. So variable, these are the variable declarations and their definitions as well. Right. Suppose starting with the first thing, bool fact. This is a boolean variable which is holding the values only true or false. So like your boolean values 0 or 1. Short max item. Maximum items they have stored in a short type of integer. Then we have long type of integer that is long. Now in this long, national debt. So they have defined the variable that is national debt. If you put a space between them, it is going to give you an error. Then our decimal point number that is pay rate. That is a pay rate and that is holding the data type that is float. Then we have double. In double, we have defined again a large range for decimal point number that is double. Then we have float complex voltage. Again, you need to have a underscore between them. Then we have character code kind. So you have two variables. One is code for storing the characters. Another is kind for storing the characters. Rather than this, you may use the underscore also between the two variable names. Int A and B. So these are the two variables that is defined as in numbers. When a variable is defined, it is not initialized. We must initialize any variable requiring prescribing data when the function starts. So basically, usually what we do in our program, like in this program, you have seen what we have done. We have just declared the variables. We have not initialized them with any values. So we usually do this thing whenever we have to initialize the variables. Later on we are going to initialize this once it is declared. Now let us move to the next part that are what are constants. Right. So constants like in variables we can change the value of variables later on and it is updated in the variable part also. Whereas when we have constants, constants are the data value that cannot be changed throughout the program during the execution of a program. Like variables, constants have a data type too. So like you have int, character, or float, or boolean, or real, complex, all these data types we have for constants also. Rather than like defining any constant, you may directly assign the particular value to it. Right, like I'm going to show you how it is used in like in our programs. Like variables, constants have a type. In this section we discuss boolean, character, integer, real, complex, and string constants. Right, so let us start with this. Our character constant is enclosed in single quotes. So whenever we define a constant, it should be enclosed in single quotes. Right, now let us I'm going to show you some of the characters and some of the constants actually, which have their symbolic meanings also. Like these are the control characters that we are going to use. Now whenever we define any character, it is enclosed between single quote or a constant value, you may use it. Right, so the first character, the first sky value is null character. Is like suppose you need to feed nothing into that variable. It is basically null characters are usually used at the end of the string. ठीक है, string में you have number of elements, at the end you need to store the null value, then we use this slash and zero. Then we have for having a beep sound or a bell kind of thing, we may use alert character, that is slash a. Right, backspace, for backspace we use slash b. For tab between various variables, we can have tab spaces between, that is slash t we can use. For new line, for generation, like move to the next line, it is slash n. Vertical tab, if we want vertical tab also. Horizontal tab mein direct t. If we want to have vertical tab, then we have to type v for it. Then we have is form feed. Form feed में we use F. Carriage return R. Single quotes, if we have single quote, then put single quote. If you want to have double quotes, then put double quote. Backslash, you may use one slash is always used for each of the characters, control characters. But if you have double backslash, that is representing the backslash also. If you have single backslash, that does not have any meaning. So you need to have double backslash for specifying the backslashes. Now let us see this part also, what are integer constants and how it is holding the values. The first representation is plus 123. The value is 123. What is the type of this? That is integer. Again, one value is minus 378. Representation is like this only. What is that? Minus 378, and it is basically which type of data it is holding, that is integer. Then we have another constant, that is L. L is representing the long. Right, you have an integer value, but that is long. So how it is having the value? Minus 32 comma 271, and then which type of data it is holding, that is long integer. Right, then we have unsigned long, L and U, that is representing unsigned long. 76542 LU, that is unsigned long. 76,542. This is how we are basically specifying the different ranges of values in a variable. Right, LL is again we are going to define any long integer. Now this is the double representation, real constants, how we basically have real numbers and how we define the real constants, real values of constants. So this is how it is, like 0.1, it is the value should be, obviously it is a double, so it is in a floating decimal point number. 0.0. 0.0, it is same, 0.0. 2.0, 2.0 will remain 2.0. 3.1416 same. Minus, now F is for float, so may not be represented as F. The value will be represented as minus 2.0. Then we have L. L stands for long, and it is a decimal point number, so it would be, and it is a long, then we will be taking the data type constant as double. Now use single quotes for characters constants and double quote for string constants. So basically there is a difference between both of them whenever we define the constants. If we are using the character constants, we will be enclosing them with single quotes, and if we are using the string constants, we are enclosing them in double quotes. So this is the basic difference between them, right? Now let us see the memory constants, how we define it in a program, right? This program demonstrates three ways to use constants. So let us see the different ways of defining the constants. Now I told you in the last session also how to use basic program, how to write a basic program in C language, right? The basic program in C language is, first of all, you need to include the preprocessor directive, right? Then you define macros or global declarations. After that, main function. So main is the heart of the C program. After in main function, you define the local declarations, statements, and whatever the function is, like calling of any function, or you may have printing of any statements. You may do it with the help of main function, right? So let us start with that. First, we have included one file, that is stdio.h. Now, what do you mean by stdio.h? That is standard input output header file. So this is the main file which is storing all the definitions, all the, like, what is constant, what is double, what is void. All these keywords are stored in which library, which header file, that is stdio.h. And hash is a preprocessor directive which is used, include is a keyword which is used to include this header file, right? Now next thing we have used is, we have defined one macro which is holding one value, right? Now what is that? How to define this? Hash define is the hash is the preprocessor directive, define is the keyword, variable name is pi, and what pi is holding, what value, that is 3.14, and it is basically defined in global declaration space. So pi can be used as any of the function throughout the program. The value would remain same in all the functions, right? If we are using this global variable. If we have again defined this pi in some other inside the block of statements, and we have changed the value, then their scope is local within that particular function. So I will be giving you the difference between local variables and global variables. I will be creating one session for that, because that is very important, how we define the scope of a variable. So it could be a global, it could be a local. Now if it is defined outside the any function, if it is defined outside the function, it is to be treated as global variable. Whereas when a scope of a variable is local, that means it is used within that function only. We cannot use it outside that function, right? So there are two ways of declaration. The first way is, you define the function with local declaration within the functions, global declaration outside the function, right? The next thing is, we have taken int main. Int main means main is returning which type of data value, that is integer type. And what is the arguments in the main function? That is void, right? Then we have some local declaration. Const is the keyword for defining the constant. Double is the data type, which, what is the variable name? CPI, which is basically holding the value of pi, and pi we have already defined in the global declaration, that is 3.14 the value of pi, right? Then semicolon, I told you semicolon is used to end the line, end the statement, right? Then we move to next statements, and we have basically printed two statements in which we have defined, which we have printed. How to print it? Printf is the command to print the message on the screen with some values. It has some expression like. So it is written defined. So within double quotes, whatever is written, it is basically printed as same. And what is this percentage f? F means holding the float value. If it is D, holding the integer value. If it is C, holding the character value. So according to the data type that we have understood in the previous slides, we have to define it in the print statement also. So what is printf slash f? Modulus this percentage f, that stands for float numbers. If we are printing the floating point numbers, if it is D, integer numbers, and if it is C, characters, right? In the next statement we have written memory constant, that is CPI. Now we are putting the value of CPI again, that is percentage f, right? So one time, like our global declaration, we have defined it as pi as a global variable. Within the variable local declaration, we have defined a constant value, constant variable, that is CPI, which is holding the value of pi itself. Now let us move to the next part. Now we have taken the literal constant. In literal constant, what we have done, slash percentage f we have used, but it is holding the value also, right? That is 3.14, the same value of pi, right? Now what are the results? Then we have taken the return 0. Why we have taken the return 0? Because in the this main function we have taken the return type as integer. So return function will return the value that is integer. You cannot have here 0 0.0 because it is returning the integer value. So you need to return it an integer value. Then this braces should be like, you have open this braces, then you have closing braces also. If you are not putting the closing braces, or if you are not opening, if you are not using the closing braces, or like it is a case sensitive language, it is going to, and it is a it is going to give you a syntax error, right? Like everything is stored in the memory. The compiler checks like the braces are on, where it is off, where it is basically, where is the closing brace of that. So whenever we define it, we need to define it like this also. This is the end of main. Well, now what is in the previous session I told you about double slash is used to mention the comments, right? So double slash is what? Double slash is comment, right? Now results, what is the output? Now we have printed in the this statement double quotes mein, I told you this is a message, define constant. In the second statement we have taken memory constant in double quotes. In the third statement we have taken literal constant, right? And all these three values are holding pi, and the last value we have printed with 3.14. So it is going to print the value of pi, and pi we have defined it as a global variable. Pi, the value it is holding, that is 3.14159.265 and 36. So it is going to print the same values for all the variables, right? It is going to print the same value for all the constant, whether it is a defined constant, whether it is a memory constant, or whether it is a literal constant. So this is how we define variables, how we use the data types for defining our variables, and how we are going to use them, like it is in a global area or it is in a local area. Global area means we are defining anything which is outside the main function, and if it is defined within the main function, that means it has some local scope, right? And if it is defined outside the function, then it would be treated as a global declaration, right? So hope you have understood the data types that we have in our C language. Hope you like the session, and in the coming session we will be learning more about the C language, C programming language, like how we define variables, how to write actually the programs, right? How to take the values as an input, how to print those values, and how to define the various data types, right? So we will be using in the coming session, we will be using all these concepts, right? So thank you.